You've now reached the third video. In this video, we're going to talk about radicals. We're going to look at simplifying, dividing, rationalizing, and we're going to look at Pythagorean theorem. So take a moment and fill in the notes section of your worksheet. Now let's work through the examples one by one together. To simplify radicals, what you want to do is break down the number underneath the radical. To make this a little bit easier, you want to break them into perfect squares. So think of the perfect squares and what perfect square will go into 48. 16 is a perfect square and goes into 48 3 times. So we've broken down the radical into radical 16 times a radical 3. And radical 16 is 4, and radical 3 or square root of 3 cannot be broken down. So my reduced or simplified radical will be 4 radical 3. Let's look at division. In this division problem, if you can simplify or divide 8 by 49, do so. But we can't, so another suggestion is to make it a radical over another radical. Now can we simplify separately? The square root of 8, you want to simplify like we did above. Try and break it down into perfect squares. So 4, which is a perfect square, goes into 8 2 times. So I can change radical 8 into 2 radical 2. Radical 49 I know is a perfect square already, and that perfect square will be 7. So my answer to this division problem is 2 radical 2 over 7. Rationalizing. Now we're not allowed to keep radicals in the denominator. Okay, this is not a simplified form. So what you want to do is multiply both the numerator and the denominator by the radical that's in the denominator, and don't forget to reduce. So I have radical 5 in the denominator, so I'm going to multiply both the top and bottom by radical 5. In my numerator, I'll have 2 radical 5, and in the denominator, I'll have radical 5 times another radical 5. Think about what that gives you. That gives you the square root of 25, which is a perfect square of 5. So basically, the two like radicals, the radical disappears, and we have just a 5. So my final answer, 2 radical 5 over 5. Lastly, let's look at Pythagorean theorem, which is a squared plus b squared equals c squared. C will be the hypotenuse side, and the other two sides you can label a or b, it doesn't matter which. So in the example, I can label the 12 the a, the 5 the b, and c is the hypotenuse because it's opposite the right angle. So let's figure out what c would be. I'm going to plug it into the Pythagorean theorem. So a squared, or 12 squared, plus b squared, or 5 squared, equals c squared. 12 squared is 144, plus 25. Adding those two together gives me 169 for c squared. And then to solve for c, I'm going to take the square root of both sides. And that will give me a value of c to be 13. Now let's look at the example problems at the bottom. For the first 12 problems, you're going to be simplifying the radicals. So try and break down 1 through 4 into perfect squares. On the next section, 5 through 8, you see division. So if you can divide, do so. Otherwise, split it up into 2 separate radicals, one on the top, one on the bottom, and then try and reduce each separately. Notice in the next row, 9 through 12, you'll be needing to rationalize your denominators. And then finally in the bottom 3, you're going to be using the Pythagorean theorem to find the missing side.